In this video, you will learn about linear programming and how to solve some linear programming problems. So what is linear programming? A linear programming problem deals with the optimization problem of two linear variables, and the function formed using those two linear variables is called an objective function. And the objective function is in the form z equals ax plus by, where a and b here are to be maximized or minimized depending upon the condition that is given. Well, the LPP, or the linear programming problem, is subject to constraints of linear variables which are non-negative and satisfy the sets of inequalities. So what are these conditions that are called non-negative constraints? Okay, the non-negative constraints are x greater than or equal to 0, and then y is greater than or equal to 0. So these are the non-negative constraints. And then we have another constraints, which are the linear inequalities or equations on the variables of a linear programming problem. And then we have the feasible region, which we call R. And this region is common to all the constraints, including the non-negative constraints. We call it as feasible region. So we have important results here. We have two theorems. The first one is we let R be the feasible region for an LPP and B the objective function. The optimal value of z must occur at the corner point of the feasible region. And then the other theorem is that we let R be the feasible region if the R is bounded, then the objective function z has both maximum and minimum value in region R, and both of them occur at the corner points of R. Whereas if R is unbounded, then a minimum or maximum value of objective function may not exist. All right. And then there is one method that we can use in solving LPP, and that we call it as corner point method. So in this method, we just have to graph the given constraints and then find the feasible region R, and then get the corner points. Then substitute the corner points to the objective function to solve for the maximum and the minimum values. All right, let's solve some problems here. In exercises 13 and 14, sketch the region determined by the constraints. Then find the minimum and maximum values of the objective function and where they occur subject to the indicated constraints. So let's solve number 13 first. So we're given here the objective function z equals 6x plus 10y, and then the given constraints x greater than or equal to 0, y greater than or equal to 0, and then our inequality, linear inequality 2x plus 5y less than or equal to 10. So let's graph the constraints first. Okay, now let's solve this linear inequality here first. That is 2x plus 5y less than or equal to 10. So let's equate this to 10 first, and then we graph the linear equation. So we subtract 2x from both sides. This cancels out. So we have 5y equals negative 2x plus 10, and then we divide both sides by 5. Then this is just equal to y equals negative 2 over 5x plus 10 divided by 5 is 2. Okay, therefore the slope of this line is equal to negative 2 over 5. So let's try graphing this. Y equals negative 2 over 5x plus 2. All right. So when x is 0, we substitute 0 here. So when x is 0, y is 2. So when x is 5, y is 0. So this one is 5, 0, and this one is 0, 2. And then we draw our line. Here. Alright, so this is our line here. And then it says less than or equal to 10, or less than or y is less than or equal to negative 2/5 x plus 2. So that means all of the points below this line. It says equal, so this one is solid. This extends here. And then we have x greater than or equal to 0. So this is x, the x-axis. So greater than or equal to 0. And then y greater than or equal to 0. Therefore, we have this region here. This one. So this is our feasible region R. And now from this region, we can get the corner points. Alright. So the corner points here are 0. They are just the vertices of the triangle because it forms a triangle here. So we have 0, 0, 0, 2, and 5, 0. And now let's try to plug in these values to our objective function, which is z equals 6x plus 10y. So that would be z equals 6 times 0 plus 10 times 0. So this is 0. Then z equals 6 times 0 plus 10 times 2, and this is just equal to 20. And then z is equal to 6 times 5 plus 10 times 0. So this is 30. Therefore, the minimum value of the this objective function is at 0.00. This one. And it's equal to 0. So this is the minimum. And then the maximum value is at 0.50, which is equal to 30. Minimum value at 0, 0. And then maximum value at 50. Alright. So let's solve the other problem. Alright, here we're given the objective function z equals 7x plus 8y, and then our constraints are x greater than or equal to 0, y greater than or equal to 0, and we have x plus 1/2 y less than or equal to 4. So let's graph the linear inequality first. The x plus 2y, 1/2 y less than or equal to 4. So let's graph the linear equation first. So x plus 1/2 y equals 4. So this is just, we subtract x from both sides. So we have 1/2 y equals negative x plus 4. And then we divide both sides by 1/2. So y is just equal to negative 2x plus 8. So the slope here is equal to negative 2. So let's graph this. Alright, so when x is 0, y is 8. So this is 0, 8. And then when x is 1, y is 6. So this one is 1, 6. So our graph looks like this. Okay, let's look for another value. When x is equal to 4, then y is 0. And we can now graph our line. Do our line here. Alright, so that is our linear equation. The graph of our linear equation, and it says less than or equal to negative 4, or y is less than or equal to negative 2x plus 8. So that means we shade all of the points or values below the line, including the line, because it is less than or equal to. And then we graph the other constraints, x greater than or equal to 0, and then y greater than or equal to 0. So our feasible region would be this region here. Okay, this one. Now we have corner points, or our vertices. We have 0, 0, 0, 8, and then 4, 0. And now let's plug in everything to our objective function to find the minimum and maximum values. Well, it would be z equals 7 times 0 plus 8 times 0. This is equal to 0. Z equals 7 times 0 plus 8 times 8. This is equal to 64. And then z is equal to 7 times 4 plus 8 times 0. So this is 28. Therefore, the minimum value of e objective function is at 0, 0, and it's equal to 0. And then the maximum value is at 0.08, and it is equal to 64. Alright, so those are two of the examples in solving linear programming problems. We will solve more problems in the next video.